I welcome you all for today's class, analog and digital data conversions. In the previous class we have discussed about op-amp, operational amplifier, its applications, features, then input terminals, output terminals, like inverting input terminal and non-inverting input terminals. In this class we are going to discuss about digital data conversion. So basically in electronics there are only two classifications, like analog communication and digital communication. So all our day-to-day life is in analog signals like temperature, velocity, pressure, etc. etc. In order to access some mobile phones or our systems, any other system, we need to convert it into a digital form. Only then we can access the analog data. So in this image you can see, if I need to stream a music, I need to browse it from any website like Instagram, YouTube, anything else. Then that signal is converted into electrical signal and in our mobile phone. Then from there conversion takes place and it is passed to our speaker where we hear through our ears. This is what the system here, both in transmitter and receiver port, they are using ADC and DAC conversions. First, let us discuss about analog to digital conversion. Analog to digital conversion is nothing but a continuous form, and digital to analog system is nothing but a discrete form. These are the two concepts used in analog and digital conversions. So ADC is a continuous form and DAC is a discrete form. This ADC is the process of converting a continuous analog signal like voltage, sound or light into a digital signal. In this image from the mobile phone, in the previous image we have seen how it is converted into speakers, and here we can see from the mobile phone again it is converted to ADC, that is analog to digital conversion, and from that it is converted into transmitter section, and from transmitter it is converted into an antenna. From that antenna only we are receiving all the data. So this ADC is the process of converting a continuous analog signal like voltage, sound or light into a digital signal. This ADC samples the analog signal at regular intervals, which quantizes the sampled values and then encode them into digital format, typically a binary number, that is our zeros and ones. There are three types here in ADC, that is successive approximation type, and second one is dual slope, and third one is delta sigma converters. We are using three concepts in this ADC. One is sampling and another one is quantization and third one is coding. These three key concepts are used in our ADC. That is, in the transmitter section we have discussed what are all the process takes place, and from the antenna the data is received in the receiver section, and from receiver into DAC, that is digital to analog converter, and from digital to analog converter the receiver port is received to any speaker or any ears wherever we need to receive or hear the data. So these concepts taken place in the converters like sampling, quantization, coding. We know very well sampling is nothing but taking periodic snapshots of ADC, and quantization is nothing but discrete digital value, and coding representing the quantized values as binary number. The applications of ADC is audio recording, image processing and data acquisition. So the vice versa of ADC is DAC, like which converts digital signals into a continuous analog signal. Here we have two types. One is weighted resistor DACs and another one is auto or ladder DACs. Here also there are key concepts like decoding and output, which decodes the signal digital input and determines the corresponding analog value. The applications here are audio playback, display system and control systems. So these are all about ADC and DAC, that is analog to digital conversions and digital to analog conversions. Thank you.